Welcome, everyone, on behalf of Dallas College and the sustainability team. My name is Faye Davis, and I am joined by my team member, Sonia Ford, who is working in the background. And I am also grateful to have a member of our Dallas College WebEx support team joining us. And so, without further ado, I'd like to introduce your speaker. We have the honor of having Dan Moulton joining us today. Daniel W. Moulton is a wildlife ecologist with a BA in biology and a master's in wildlife ecology and a PhD in wildlife science. He has a postdoctoral research, he is a postdoctoral research fellow at the University of Minnesota in Minneapolis, St. Paul. He is recognized as a certified wildlife biologist by the Wildlife Society. He has worked for the U.S. Fish and Wildlife Service in Hawaii and Maryland, the Maryland Wildlife Administration in Annapolis, and for over 20 years at the Texas Parks and Wildlife Department in Austin. His work at TPWD focused on wetland ecosystems all over Texas, but especially coastal wetlands. After retirement from TPWD, he taught for over 6 years as an adjunct professor of environmental science and biology at several colleges in the Dallas area. He presently serves as the executive committee chair of the Dallas Sierra Club. Thank you so much, Dan, for joining us, and please go ahead and get started whenever you are ready.
Okay, good afternoon. We're going to talk about water today. This picture you're looking at now is from Lagos, Nigeria. More than 1 billion people around the planet do not have access to adequate, fresh, clean water. Many of those, over 1 billion, have to get by on 2.5 gallons of water per day. Plus, they have to spend more money than the rich people to get the water. Plus, it's not safe, so they have to use fuel to boil the water. In contrast, your average American uses perhaps 40 gallons a day. Okay, quickly, we're going to look at the hydrologic cycle, which is one of the major biogeochemical cycles that keeps life going on Earth. Water use problems, we won't do so much global. Water management, water conservation. Well, you all know how important water is for various activities: cooking, washing, drinking. We use large amounts of fresh water for these activities. Most of it goes for agriculture around the globe and in the US, and for individual homeowners because of irrigation of lawns. 71% of our freshwater use is agriculture. About 20% is from manufacturing, mining, and energy production, and 9% is domestic and municipal use. And of course, as the Earth's population increases, our use of fresh water increases. This is not a chemistry class, so we won't study this too hard, but water is one of the most remarkable chemical compounds that exists as far as we know, certainly on Earth. H2O can be a solid, a liquid, or a gas. It has a high specific heat, which means you have to pour a lot of heat into it to get it to heat up, and it's slow to give off its heat once it has captured heat. That's one reason why the oceans of the world modify climates. The heat given up very slowly. The water molecule is called polar. That is, it has a positive charge at one end, a negative charge at the other. This causes these hydrogen bonds to form, as we see in B in the example there. And those hydrogen bonds actually define the physical properties of water. When water freezes, the molecules distance themselves equally from all the other molecules. That makes it lighter than liquid water. That's why ice floats on top of liquid water. If that were not the case, we would have a very different world if everything froze from the bottom up, including, polar oceans. As it is, water freezes on top and then insulates the water underneath. Let's look at some properties of water here on the planet. It's never totally pure, of course. And if you look at the left, you see what seawater consists of. Out of 1,000 grams of seawater, 965 are fresh water, but 35 grams is salts, mostly sodium chloride. So that's why seawater is 35 parts per thousand salt. There are other elements, potassium, calcium, magnesium, that are present in sea salt, not just sodium chloride. That's why a lot of people prefer to use sea salt rather than just pure sodium chloride. You do get other nutrients from the seawater. Now, water is called the universal solvent. It's not really, but it does dissolve a lot of things, especially if they are polar substances that have charges at one end. That means that a lot of things that dissolve in water are going to cause pollution. The hydrologic cycle is very important, and we just need to take a quick look at it. It's one of the major biogeochemical cycles that makes life on Earth possible, along with others such as the carbon cycle. What happens is water evaporates from the surface of the ocean and from rivers, lakes, and streams, and from the soil. It is, as a vapor, it's carried into the atmosphere, and then and this is caused by the heating of the water by the sun. Also, the movement of wind is caused by the sun. So the sun drives the hydrologic cycle. The water vapor moves in the clouds and then falls on the earth. And then eventually it makes its way back to the ocean or to rivers, lakes, and streams. And this is a cycle that goes on, and this makes life possible on land. What about the distribution of water on the planet? You see from the figure that about 2.5% of all the water on the planet is fresh water. The rest, 97.5%, is seawater, which we cannot use directly. Of the 2.5%, 2% is in the form of ice, as you see that inset at the bottom. Only less than 0.5% of the water on Earth is available for us to use as fresh water. And of that, we use more than half of it, just humans alone. Here's some terminology I don't know that we need to study. An aquifer is an underground water that is in sand or gravel and rock, which can be pumped to the surface to provide us with groundwater. So this is a freshwater aquifer, and a lot of us get water from these aquifers. For example, San Antonio draws almost all of its water from the Edwards Aquifer, which is in the hill country of Texas. And you see the confined aquifer would be like the Edwards Aquifer. The water penetrates the limestone in the hill country, flows underground, flows downhill. We have all of these springs like Barton Springs in Austin and Comal Springs are Edwards Aquifer water, and they are artesian wells, essentially. Water use and resource problems. Well, there's three basic problems or categories. You can have too much water, that's called a flood, too little water, a drought, or poor quality, that is polluted water. Too much water is, flooding, natural and human induced. We cause a lot of these problems by removing the natural surface of plants from the soil and then building highways and buildings and other impervious structures that will not let water absorb into the soil. Instead, it runs off, and we'll talk about that in a minute. A floodplain is an area bordering a river that has a natural potential to flood. Building on floodplains is another problem that we cause ourselves. Let's just take a quick look at this because this is interesting to me. You have an urban versus a pre-urban floodplain. Urban would be a good example would be the Houston area that floods every time there's heavy rain, right? In the pre-urban area, we have 50% of the precipitation goes, percolating into the ground and becoming groundwater. The surface, that's because the plant cover allows for that to happen. Only 10% runs off to feed rivers, lakes, and streams. And 40% is evaporated or transpirated back into the atmosphere and may move to a different area and cause rain there. Once the area is developed, such as say an urban area, we're going to get a lot more surface runoff because of these impermeable surfaces, roads, buildings, storm sewers. The groundwater decreases. That's going to mean that the water level goes down. Some wells may go dry because of that, and it'll cost more money to pump the water up from the water table because of that. Less water is going into the air also, which may affect the rainfall in other areas. Floodplain. Okay, there's some flooded houses, and this just says that we shouldn't build on floodplains, and you have to expect floodplains are going to flood, and we should stay back off of those. Here's an example. What we have in Dallas with the Trinity River is something similar to the top picture there, where we have levees. We try to control the river. It's channelized and the banks are fortified. Down below, even though there are levees, the floodplain is wider. The river is allowed to meander. That area can flood. It can also support vegetation. The buildings are set back behind the levees farther. So as I say, the Trinity as it flows through the Dallas area is a good example of that top picture. I don't think we'll talk about the floods of 1993. No time for that today. Now, here's a problem that affects us in the Southwest. Too little water. Okay, this is typical of arid lands, of course. Problems are drought, overdrawing water from aquifers for irrigation purposes primarily. This aquifer depletion, in addition to causing the water table to go lower, it will cause subsidence of the land and sinkholes to form. We have some of that going on in West Texas now. This picture shows, I believe, is from Nebraska. We have the same thing in the high plains of Texas. These are center pivot irrigation systems, and that circle is covering pretty much a whole section, and they draw water from the water table, which there's the Ogallala Aquifer I'll mention later. Too little water. Here's a problem we have on the Texas coast and really all coastlines around the world. If you pump too much water near the ocean, the water table rises and brackish water tends to penetrate farther inland from the salt water. When this happens, you can get salt water coming into your well. We have this problem on the Texas coast. There are some small towns on the coast that cannot drink their municipal water. They have to buy bottled water. And this is the reason why right here. It's called saltwater intrusion. Water problems in the U.S. and Canada. Let's just take a quick look. It says the U.S. has a plentiful supply of fresh water, but it also says many areas have shortages due to their geographic variations and seasonal variations in rainfall. This is an interesting map because it basically shows annual precipitation for all of North America. You can quickly see that there's more rainfall along the East Atlantic side than there is going west across North America. Until we get into the desert areas. Over here, we have the Chihuahuan Desert, which is part of Texas. We have the Sonoran and the Mojave and the Great Basin Desert. The definition of a desert ecologically is any area that has 10 or less inches of rainfall per year. So you can see that the southwestern part of this country is having problems with water supply. Let's just take a quick look at precipitation in Texas. And you see this is a very interesting zonation. You can't read these numbers, but that says 56. So over here in Orange, Texas, on the Sabine River, adjacent to Louisiana, we have 56 inches of rain a year. That gives you cypress swamps and makes it look just like Louisiana. As we go west, it decreases. Our area right here has about 36 to 38 inches precipitation per year. But in El Paso, it's 8 inches of precipitation per year. So that's an official ecological desert. And all of this area here is part of the Chihuahuan Desert. This zonation does give us our very diverse ecological diversity in terms of plant and animal communities because of these zones. Water problems. Well, in the west and southwest, water diversion and transportation via aqueducts is common, especially to the cities in California. Water problems in the U.S. I don't think we'll talk about Mono Lake, that the water was basically drained out of it to send to Los Angeles. It became highly saline. That led to legal battles, court-ordered water diversion reduction to try to reclaim the Mono Lake ecosystem. Now, the Colorado River Basin provides water for 27 million people, and various dams produce electricity for those people. The Colorado River empties into the Gulf of California in northern Mexico. It used to. It doesn't anymore. It looks like this now. This is the bed of the Colorado in Mexico. The water is all drained off by the United States. A lot of it goes to California and other points west in the All-American Canal. Now, where the Colorado used to empty into the Gulf of California, there was a major estuary supported by that water. And that estuary supported a major fishing industry, which was no longer exists, obviously, because there's no fresh water coming in. Let's talk about groundwater for a minute. Here is a picture of aquifer depletion, that is pumping too much water out of the ground for the whole country. And again, you can see the Southwest, and this is the Ogallala aquifer, I'll show you in a minute, is the one that's in trouble. Okay, because these are arid regions, rainfall is not adequate, so they're getting the water out of these aquifers underground. As you lower the water table, it becomes more expensive, by the way, to pump water. This is a picture of the world's largest underground aquifer called the Ogallala. Here's Texas. This is the high plains of Texas. And up here, where rainfall isn't very much, water from the Ogallala aquifer is pumped out to support major agriculture like corn, wheat, and so on. And you can see that they're in trouble. This is a decline in feet, more than 100, all of these areas here. Sometimes people say the Ogallala can't be replenished in its mind. But if you look up in Nebraska, these areas are actually gaining. The water table is rising. So that's not completely true. It is, however, for us, for most of Kansas and for all the Texas high plains. We won't study this too hard. It shows domestic water use in gallons per day per person and the projected percent population change by 2030. And the range was from 2004 to 2030. So most of these increases have already occurred. Well, again, you can see domestic water use is very high, 114%. This is probably mostly Las Vegas, okay, doing that. 109, Phoenix and Tucson. Texas isn't quite so bad, but we use a lot of domestic water. And as I say, on average, it comes out something around 40 gallons per person per day. And of course, these are the areas that are going to see trouble in the future. and probably Texas too. Global problems include climate change, drinking water, population growth. Of course, that's all over almost, and sharing water resources among countries or states. Climate change affects the type and distribution of precipitation. For example, in the West, snowpack in the mountains provides most of the fresh water that is used in the western states. And a reduced snowfall is going to have serious impacts on water resources downstream. And again, sea level rise is causing saltwater intrusion to get worse and get into drinking water supplies. All right, well, this is obvious. As population grows, more fresh water is needed, and drinking water becomes limited. Water availability for agriculture becomes limited, and that may affect food security in many parts of the world. I don't think we'll talk about problems in Europe right now. We have enough problems of our own. We just will look at the Aral Sea. What happened in the Aral Sea, I'll tell you in a minute. The Aral Sea is east of the Caspian Sea, and on one side is Uzbekistan, and on the other side is Kazakhstan. And these were a part of the Soviet Union in 1967, when the Soviet Union decided they wanted to make a major cotton growing area out of this region. And so what they did, of course, was siphon off water from the two rivers that flowed into the Aral Sea. And then by 97, it's worse now, it looked like this. And this destroyed many fishing villages around here, caused wind to blow salty dust across large areas. And it's usually pointed at as a major ecological disaster that was created by the Soviet Union. Volatile international situations. We have the Nile in Africa. Problems going on there with countries such as Ethiopia and Somalia and Sudan. The Jordan River in the Middle East, there's always been problems there. Water wars actually may, be fought in the future. Water management. The main goal of water management is to provide sustainable supply of high quality fresh water. This will require that we use the resource carefully. Dams and reservoirs provide water. They also have their problems. Water diversion projects, same thing, and they have their problems. Desalinization is not practical except for very rich areas like Saudi Arabia because it's so expensive. What are the benefits of dams and reservoirs? Well, one is you get a year-round supply of water with a regulated flow. Also, many dams generate electricity, and of course, they provide recreational activities. The problem with them is they alter the downstream ecosystem. They do that by reducing the sediment load in the water, which is, if a river doesn't flood its floodplain, it won't supply nourishment to the floodplain in the form of sediment and water. And when the river gets to the sea, there's an estuary. And what happens there is a good example is the Mississippi Delta in Louisiana. They've cut off so much sediment supply with dams, locks, and so on the Mississippi that the whole Birdfoot Delta of the Mississippi River is sinking under its own weight and not being built back up with new flushes of sediment every year. This is Glen Canyon Dam on the Colorado. I don't take too much time on this. When you cut off the natural flow of floods carry sediment. They wash away sediment on the river bottom, which is important for many organisms, fish and mussels, freshwater mussels. These sandbars are important for many animals, such as some birds that nest exclusively on these. When you do not have these floods, because you've got a dam and they don't release water, a thick layer of sand and sediment builds up on the bottom. This is very bad for our native freshwater mussels. These sandbars tend to erode. That's bad for certain birds. Regulated flows can help bring back some of these habitats. This is when they open the dam and allow a flood to take place in a regulated manner. Okay. Another problem dams have caused on both coasts really is salmon populations have gone down because these dams get in the way of migration. This is a picture of a fish ladder where the salmon are supposed to come around the dam by going up these steps and then, getting in the reservoir behind and continuing on upstream. These help, but they haven't helped enough. Right now, the country is in the process of removing a lot of dams that are no longer considered to be necessary. Many of them are on the East Coast. Smaller dams generally. Water diversion projects. And of course, California is famous for this. You have to divert water in the area where it's available and then pump it or run it through a system of aqueducts where the water is needed. Let's say San Francisco or Los Angeles or San Diego. That's where California cities get most of their water. It's from Northern California, and it's pumped or pipelined or in aqueducts. It's controversial because it tends to destroy the areas where you're getting the water from. There was a big controversy about building a dam in the Hetch Hetch Valley of Yosemite National Park. They did that because of the big San Francisco fire that took place after the earthquake. They didn't have enough water to put out the fire, so they decided to build a dam inside Yosemite National Park. And that's still there, still providing water for San Francisco. And of course, any kind of a deal like this is going to be expensive to move water, no matter how you do it. Desalinization, you can remove the salt from the ocean water. One way is distillation, where you simply allow fresh water to evaporate from the salt water, and then it condenses to fresh water. This is how a lot of ships get their fresh water. They have a distillation still on board the ship, especially Navy ships, and they produce their own fresh water that way. Reverse osmosis is a chemical process where you force salt water through a permeable membrane that doesn't allow salt to get through. And that is a very expensive proposition. They do this in Saudi Arabia, where they have a lot of money and no water. There are some small cities in Florida that are doing this also. Let's talk water conservation for a minute. As we said before, 71% of all freshwater use around the world is used for agriculture. And that includes not only commercial agriculture, but domestic and municipal agriculture, which is growing a lawn, growing flower beds, and so on. Agriculture has historically been very inefficient in the way they use water. New systems are coming online, like micro irrigation. Here you have irrigation that conserves water because it pipes the water directly to the plant, actually, that needs it. Also called drip or trickle irrigation. You see that pipeline would be up there on the top and would deliver water to each plant kind of continuously throughout the day. And this saves a lot of water. Industrial wastewater. Industry wastes a lot of water too. We can deal with that with laws that provide incentive to conserve the water or recycle the water within the facility. Water scarcity, it says, in addition to stricter pollution control, will encourage further industrial recycling. And the potential to conserve water that way is very large. Some industries are worse than others, of course, in the way they use water. Here's water conservation at a municipal level. This is a house. Now, this harkens back to the old days when a home, many homes would have a cement cistern in the backyard, and all their gray water would go into that cistern, and then they would use that to water their garden and water their lawns and gardens and so on. Today, gray water storage would be done by putting a tank, and all the water except the toilets would go into this gray water container here. The gray water itself then can be used to flush your toilets, which will go down, into the sewage system, to wash your car or water your lawn or garden. Another way is you can use water-saving household fixtures, shower heads, faucets, toilets that use less water, and so on. Government incentives, all right, like giving you a deal if you buy appliances that use less water, like a washing machine or maybe a toilet that would use less water than non-water saving appliances. I believe this is my last slide, so we can take a little bit more time with this. What can you do at your house? Well, in addition to some of the things we just showed here, and when a new home is built, you can have this gray water storage tank put in it. Or if you wanted to go back to the olden days, you could have a cement concrete cistern buried in your backyard where the water would go, and then you could just pump it up out of there for all of these uses here. What can you do in your own home? All right, well, we've already said you could install the water shaving shower heads, faucets, low flush toilets. If you know you have a water leak of any kind, even if it's just a dripping faucet, you should fix that. Or toilets that don't shut off properly, and are continually going on as the tank fills back up a little bit, you can fix that. You can purchase high efficiency appliances such as dishwashers, clothes washers that use less water. And you might get a government subsidy deal on the purchase of those appliances. You can modify your personal habits. What does that mean? Well, when you're brushing your teeth, for example, don't let the water run the entire time. Wet your toothbrush, turn off the water, brush your teeth, turn the water back on. You can do the same thing when you're showering. This is when you're on board ship, this is called a sea shower, and you have to do this because their fresh water is coming from these distillation stills, and so they have a limited supply. So what is a sea shower? You turn on the shower head, you get wet. You turn off the shower head, lather up, and you soap up. You turn the shower head back on and you rinse off, okay? And then off. So you've saved a lot of water, rather than if you let that shower run the entire time you were shampooing and soaping up your body, okay? Use the dishwasher. Some of you may find this a little surprising. Use the dishwasher instead of washing dishes by hand. And the reason for that is a lot of people allow the water to keep running while they're washing dishes by hand. And today's modern dishwashers are very efficient in the way they use water. The xeriscape. What is a xeriscape? A xeriscape is a landscape that uses native low water plants, such as succulents, cacti. There, unfortunately, is no grass that is what you could call a xeriscape grass, except for maybe some native grasses like buffalo grass. So you see a lot of this in the Southwest where they have gravel yards, and coming up out of the gravel, they have succulents and cacti and so on. Another thing that you can do is to harvest rainwater from your roof. You have barrels that you can, let the drains go into and collect that rainwater. You can then use that rainwater to water your gardens and to some extent your lawn. Well, that is the last slide I have, so I went faster than I needed to, but I guess that would leave more time for me to try to answer some questions.
Thank you so much, Dan. Very informative. And I think someone in the comments also said this. I had no idea that a dishwasher was better to use than washing by hand, so I can get rid of that guilt. But yeah, we do have a few questions for you. So the first question is the U.S. the largest consumer of water?
Is the United States the largest consumer of water? Well, I don't really know the answer to that, but because I don't know how much water they use in China, for example. If you want to look at domestic use, that is used by municipalities and individual citizens, then yes, definitely. But there are some countries that have a lot of agriculture. Russia's one of them, China. They may be using more water for agriculture than we do. That's the best I can do on that question.
No problem. Thank you. Next question. Since the majority of water usage is used for agriculture, are there solutions being developed for water usage in farming practices?
Well, certainly there are. For example, in the high plains where you saw that center pivot irrigation system, they used to have spray nozzles way up high on the pipelines. I don't know if you're familiar with center pivot. And it would just go and throw water off into the wind, and it would just blow away. They now use what's called a low pressure drop nozzle, which comes down, hangs down from the water pipe just above the crop, and the water comes out low pressure, and so it doesn't blow away. So that's much more efficient. And the drip irrigation system you saw, that can't be used, say, on wheat fields or corn fields. They're too big. But that's used a lot for vegetables and fruit production. And then it'll regulate itself in some ways. For example, we looked at the Ogallala Aquifer, which underlies the entire high plains all the way up into Nebraska. And that's the way farmers used to irrigate their crops. But as that water level drops, it costs you more and more money to pump the water. The farther you have to pump, the more money it's going to cost you until it becomes cost ineffective to grow your crops. So there has been a big switch in the high plains, at least of Texas, back to crops that rely on rainwater. Wheat is one crop that there are various varieties. That's called dry land farming because you do not irrigate. It's a gamble because you don't know what the rainfall is going to be. But if you can't afford to pump water from the Ogallala, then you don't have a whole lot of choice other than to go out of business. I'm sure there are another thing that we see kind of coming online is this hydroponic farms and of course this does not apply to grains where you have miles and miles of wheat and corn, but it does apply to vegetables and some fruits. And you know what a hydroponic farm is. They don't use soil, they just use water, and they add the nutrients and the crops grow. And of course they can recycle the water. over and over again. They may have to filter it a little. So that's something we see in the production of vegetables and some fruits. I'm sure there are other techniques being developed. There's a lot of rooftop gardens going in areas, in urban areas where there is adequate rainfall to grow your own vegetables and some fruits. So the big fields of wheat and grain, that it's problematic. Because if you don't have an aquifer you can pump out of, or you can't afford to pump out of it, then you're going to have to rely on dryland farming, which is rainfall. And the problem is climate change is causing rainfall to change in various parts of the world. And it's hard to predict where those parts of the world are going to be. There are models that try to predict it. So, yeah, we could be looking at some problems in the future. Depending on what happens with climate change. Okay.
Thank you. Next question. And I guess what you just said kind of leads into this. What's the best way to water my home garden?
Well, the best way would be if you could get by on natural rainfall. That is not likely because your home garden has probably got things in it like tomatoes and onions, which need a lot of water because they're so shallow rooted. So, we have a community. I live in Addison, and we have a community garden. There's community gardens all over now. And a lot of people use drip irrigation systems there. If you have a hose bit, you can put a timer on, run the drip irrigation to your garden, and then you could, the timer will come on when you want it to come on, and then the water will just, you won't have to spray it like with a hose. It just drips into the soil by your plants. I think for a home garden, and then it will shut off when you have timed it to shut off. So you find out what is the best system for keeping your plants going. I think that's probably the best system for a home garden. The most water conservative and also the least effort. Once you get that, the drip system is just plastic hoses you connect together, and they have little nozzles wherever you want to put them in by the plants, and it's essentially maintenance free once you set it up. So I think that's the best way. Or the other way is just to use a wand and just water each plant individually, the amount that it needs, and not use some kind of a spray thing that throws water all over your yard. Although for your lawn, that's exactly what you're probably going to do. I know that's what I do because I bought a house with a water-hungry lawn, carpet grass, and the irrigation system was already put in, and so I have to maintain that. Otherwise, the homeowners association will evict me or something. They have their rules, and sometimes the rules of a city or a town really go against the best conservation uses. For example, if they would let us grow lawns with buffalo grass and say native wildflowers that could be sustained by our natural rainfall, you wouldn't need to irrigate your lawn at all. But of course, the city and the homeowners association, they won't let you do that in most places.
Thank you. I have a question for you. So let's say we continue, our water usage grows and we continue going the same path we're going down. How soon do you predict that we're going to run out of water, and what happens then?
Well, that has already happened in many areas. As I mentioned, the high plains of Texas, dependent upon the Ogallala, they cannot afford to pump the water anymore. in many areas, and so they've had to go to dry land farming. That could fail if you don't get adequate rainfall for, say, a couple of years. Now, for us, the first thing that's going to happen is the price of water will go up. I have noticed that is happening to me in Addison already, because all our water is coming from water that is purchased by the city of Dallas, and then we kind of contract with the city of Dallas to get our fresh water. And it comes mostly from the big reservoirs that we have in this area, Lake Lavon, those big reservoirs like that. And one thing that'll happen if we start to dry up, by the way, climate change models show that not all areas, the same thing isn't going to happen in all areas of the globe. Some areas of the globe may become cooler and wetter than they were before. Some areas of the globe are definitely going to become drier and warmer than they were before. Unfortunately, that's the prediction for the Southwest United States, which is what we do not need. San Antonio is another example of a city that has a water problem because they pump water out of the Edwards Aquifer to supply the city of San Antonio. And that water level is going down. So I imagine their water prices will go up. Many people who have wells in the hill country have had to dig their well deeper because the Edwards Aquifer has gone lower and their well didn't go deep enough. Now it costs you about $1,000 or $2,000 a foot to deepen a well. So that's kind of a bad deal for people whose wells are now going dry. Let's see, I may have gotten off track. Your question was about our future?
Yes.
For the world, for the country, or for Texas? Or for Dallas?
Could you go through all of those?
Well, I don't know what's going to happen around the world because, as I said, not all areas of the earth will suffer the same consequences due to global warming and climate change. And some areas may not suffer any difference. They may just stay the way they are, okay? So it's hard to generalize. As I said, the models have predicted we in the southwestern U.S. are going to get warmer and drier. In Texas, we already have problems, as I pointed out, with saltwater intrusion. That's due not only to pumping water from the aquifers there near the coast, but also to the rise of sea level due to global warming and climate change. Sea level is rising measurably, and so saltwater intrusion will get worse as that goes on. Areas like, let's say, El Paso get a lot of their water from the Rio Grande. And of course, across from the border of El Paso is one of the bigger cities in Mexico, Ciudad Juarez. Ciudad means city, of course, in Mexican, in Spanish. Ciudad Juarez is a much bigger city than El Paso. And they're getting a lot of their water from aquifers and from the river. And I don't know how many of you know that the Rio Grande, south of Ciudad Juarez and El Paso, has no water in it. It's dry as a bone. The water that is in the river, let's say in Big Bend Park, where you may have, floated the canyons, is coming from a river that flows north out of Mexico. And that's what water we have in the Rio Grande is from that river that comes out of Mexico until you get, lower down where a lot of return flows from agriculture are occurring in the Rio Grande Valley. So my first prediction is that water will become more expensive for those of us who actually have access to a clean freshwater supply. There will be restrictions, as we have seen in recent years, about watering your lawn or washing your car. That has happened right here in the Dallas area. You know, you can only water your lawn on, this day or that day. And if they catch you doing it, you'll get a ticket. So that's already been happening. What'll happen to big time agriculture? I'm not really certain about that, where they cannot rely on rainfall. The whole much water is taken from the Mississippi drainage basin in the whole central part of North America, and of course that has led to some of the problems we have on the lower Mississippi with the sinking of the delta and so on. There's not as much water coming down the Mississippi as there used to be, because a lot of it is drawn all the way down for agriculture, and in some cases municipal. Okay, remind me what else your question was about. I'm going on and on here.
No, it's okay. It's okay. And I think you've adequately answered it. The question was just what does our future look like if we don't intervene now to slow down on our water consumption?
Well, we've already seen hints about it. Water restrictions, a rising cost of water. By the way, the cost of water is a real problem in this country. It doesn't cost enough. When you pay your water bill, well, when you drive down the street and it's raining cats and dogs, and you see some industrial park or some big office building, their sprinklers are going, and it's a pouring rain, right? Nobody bothers to turn off the sprinkler system. Half of them are shooting water out into the street. Why is that? It's because they don't care enough about water, because it doesn't cost enough to hurt them if they waste it. So there's one thing we're going to have to do. If you waste water, it's going to have to hurt you financially. And what you pay for when you pay your water bill is the delivery. The treatment of the water has to be treated, of course, so it'll be safe, and the delivery of it to your home. There's a huge delivery infrastructure. The truth of the matter is the water itself is basically free, because we're not putting much value on it. But we do have to pay for the delivery system and the treatment of the water, the treatment of wastewater at the sewage treatment plant, and so on. But we're not paying very much for the water itself. And of course, people will not like that when the cost of water goes up. But that's called the fair market. And we'll have to see what happens there. There's a lot of waste that could be curtailed. And for example, for these buildings where they waste the water with their sprinkler system when it's raining, the city could come and say, we're going to fine you for doing that. And if you don't change that, you're going to get fined every time you do it. In other words, government disincentives. That's another thing. These government incentives that make the water cheaper the more you use is really a perverse incentive. Water should be cheaper the less you use, not the more you use. You should be rewarded for using less water, not for using more. And that is a government function.
Thank you so much, Dan. And in a few weeks, make sure you check the sustainability newsletter. Dan will join us again to talk about nuclear energy. So we're excited for that topic. Dan, is there anything else you want to leave with the audience in this last minute?
Well, I would just say we need to consciously start conserving water in some of the ways that I've told you about. And in some cases, it will take an outlay of money on the part of the consumer to save water. The other thing I want to leave you with is the Sierra Club is politically active. We donate money to political candidates that we feel have said they're going to support our environmental agenda. So I would encourage you not only to vote, like for city council people and state reps and so on, but try to find out what their environmental view is before you vote, okay? We interview people, we advocate for people on our website, we hold fundraisers and so on, so we're very politically active. And the point there is we want to elect government officials, especially at the level of Dallas, since that's where we operate, who are going to do things that are good for the environment, including water conservation. So please, not only vote, but find out who you're voting for and what their environmental views are. Okay? That's what I'll leave you with.
Thank you so much. I think that's a perfect ending. Well, thank you, Dan. Thank you to the audience for joining.